Okay, guys, so just a reminder that we are going to have a Google Hangout today from 2 to 3. The link is in Google Classroom, so you just click on that. It should bring you into the Hangout. Anytime between 2 and 3 that you want to come hang out, you don't have to stay the whole time. Come with questions if you have them. So our question of the day today was a reaction order problem. This is really similar to a problem that you might see on the AP test. So for the reaction of N2 plus 3H2 gives you NH3, the rate expression for the appearance of NH3 in the forward reaction is as follows. So the rate is equal to K, the rate constant, times the concentration of N2 times the concentration of H2 squared. So in this one, N2 is first order. And then H2 is second order. So overall, it's a third order. Okay? Because when you add those two together. So if the volume of the container is halved, which basically doubles the concentration of all the ingredients at constant temperature, the reaction rate will increase by a factor of what? Okay, so the rate is equal to K, which is a constant, so that doesn't change with the concentration. And we are going to double the concentration of the N2, and we're going to double the concentration of the H2. So 2 squared is 4, and then 2 times 4 is 8. So the rate will increase by a factor of 8 if we did that. Okay, so next it says using the rate law for the appearance of NH3, determine the rate law for the disappearance of H2. So what I see in this is that we're comparing two things. So I'm going to set up my rate law for my balanced equation. So I'm going to say 1/2 of the rate of NH3 is equal to, and when I look at H2 in my equation, it's 3 of them, and it's negative because it's a reactant, negative 1/3 the rate of H2. So I know the rate of NH3. So this piece here was something that I was given, and we're trying to find the rate for H2. So I'm going to multiply by 3 on each side. So it's going to be 3/2, and then instead of the rate of NH3, I'm going to put in the actual rate law. So 3/2 K times the concentration of, what is that? N2 times the concentration of H2 squared. And that will be the rate law for H2. Okay. There we go.